Wood and wood fiber. Wood is the most friendly material for humans. It provides food and warmth. It is a source and raw material for creating furniture, various tools, paper, fabrics, building materials, and serves as a means of transport. Wood fiber is the most common, useful, and sought-after wood substance. It possesses great strength, excellent biostability, and reasonable processing cost. Modern technology has allowed even greater new opportunities for its future. Conclusions. For millenniums, humans have been using wood products for building homes. It is the most useful, natural, safe, and health continence material available to humans. Production. As certified by the International FSC organization, the wood fiber underlayment products are made of select quality raw material, made of 100% natural wood fiber. No adhesives are used in the manufacturing process. The fibers are bound to each other by a natural wood resin called lignin. Conclusions. The underlayment products are not manufactured from recycled wood waste. The products are made from the highest quality selected forest pine cultivated and grown in managed forestry in Europe. Once an adult tree is processed, never burned, it is being replaced by planting a certain number of young trees. This highly managed and supervised process ensures restoring oxygen balance by recycling and reduction of carbon and gas. Sound barrier. Being a natural material, much like animal wool or human hair, the fibers are hollow inside, which allows Steico wood underlayment to exhibit the unique quality of outstanding sound insulation. Sound barrier is created because air volume present not only between the fibers, but is also trapped inside them. Artificial materials do not possess this property, which is unique to only natural substances. Conclusions. It is the hollowness of the wood fibers that distinguishes and differentiates it from all other materials. A large amount of air chambers in the wood fibers and the fibrous nature of the underlayment product ensures the outstanding sound insulation property of this underlayment. This property was tested in an accredited U.S. lab and confirmed by the strictest test available, using a 6-inch concrete slab in a structure without a drop ceiling. The test result of this product of more than 50 dB attests to the great sound insulation property of the product. Vapor permeability. Boards made out of wood fiber are distinguished by possessing a high vapor permeability. They have the capability to remove excess humidity from the premise, keeping the building structure dry. This technology is called vapor open. This characteristic of moisture permeability allows the house to breathe, eliminates conditions for mold formation, and prevents bad smells in the house. Conclusions. It is imperative to remove excess moisture from the house in order to prevent the formation of mold, mildew, and bad smells. Water resistance. Wood fiber materials have the ability to get wet and dry out multiple times without losing any of their physical and technical properties. Wood fibers are capable of absorbing excess indoor moisture for up to 20% of their mass, as well as releasing it back to the air when the air is too dry and moisture is needed. This characteristic makes wood fiber boards natural microclimate regulators in the space where they are installed. Conclusions. Wood fiber materials are not afraid of direct contact with moisture. After drying, they are restored to their original form without losing any of their properties and strengths. The presence of wood fiber materials in the house allows removal of excess air humidity during a rainy climate and eliminates dry air in instances when the house is heated in the cold season. Protection of the click-lock flooring system. Wood fiber boards are very strong and sturdy. They do not bend when pressure of up to 20 tons per meter square is applied, and at the same time, they are elastic enough to eliminate subfloor unevenness. This unique property protects the finished floor locks from squeaking and subsequent breakage. It prevents the unpleasant springy effect when walking on the finished floors. Conclusions. A soft and not sturdy enough leveling material can accelerate the wear and tear of the finished floors and cause its breakage. A sturdy material protects the floors and increases its longevity and use. A springy effect, like when walking on a trampoline, is the most common reason that people do not want to purchase laminate flooring. Wood fiber underlayment can prevent this effect and keeps even laminate floors very sturdy. High thermal resistance. When heat is applied, as with any radiant heat system, the wood fiber underlayment does not get destroyed. It retains all its geometry without losing any of its properties. It is extremely important for the underlayment to retain its size and integrity without cracking and breaking when heat is applied, since once cracks begin to occur, all heat and sound insulation properties of the product are lost. Conclusions. If a radiant heat system is planned to be installed, it is imperative to consider the thermal resistance of the underlayment to be used. Fire resistance. In case of direct fire, the wood fiber material will only char on the outer layer that comes in direct contact with the flame, while significantly hinders the progress of the flame. The inner layers of the structure are left untouched and fully protected. This attribute of the material slows down the spread of fire, protects the structural integrity of the building, and substantially minimizes damage. Conclusions. The longer the material can contain the fire and delay its spreading, the more time remains for a safe evacuation of people and saving property. Leveling of floors. If, in addition to smoothing the concrete subfloor, the floor level needs to be elevated, either a thicker underlayment board should be utilized or multiple layers of the thinner boards can be stacked up. if that is what is available on hand. When stacking up multiple layers, one on top of the other, the seams of the board should not align. The upper layer should either be laid out in a perpendicular manner to the lower layer or simply indented so the seams are not aligned with the lower level. Conclusions. Wood underlayment can be utilized as a dry leveling tool for concrete subfloors. Using this method saves time and hassle of drying and smoothing the concrete, applies less weight to the structure of the house, provides heat and sound insulation to the house. Sound insulation in walls and ceiling. Wood fiber underlayment can be utilized in combination with drywall and sheetrock for sound insulation in walls and ceilings. The boards can be installed using glue. Conclusions. Gluing wood underlayment on existing walls and ceilings is a fast, effective, and relatively inexpensive way to achieve sound insulation in a room. Preparation for installation. 48 hours prior to installation, it is recommended to unpack the underlayment and leave it laying horizontally in the space where it is going to be installed. The underlayment has to adjust to the temperature and humidity level of the space where installation will take place. Conclusions. It is always recommended to open and leave the underlayment in the space where installation will take place a few days prior to the installation. This step will prevent the underlayment from damaging and/or breakage during and post-installation. Concrete subfloor. Using the wood fiber underlayment as a concrete subfloor, leveling, and smoothing material, we will demonstrate the most effective and time-saving way to install laminate floors. Prior to the installation, please verify that the subfloor is dry, clean, and relatively straight. To ensure that, the incline of each 6 to 7 foot of floor area should not be greater than 2 millimeters, 1/12 of an inch. Since in our demonstration the incline was 1/6 of an inch, we will utilize the 6 millimeter, 1/4 inch underlayment boards. Conclusions. It is practically impossible to achieve a completely straight and smooth subfloor, and therefore the wood underlayment is a simple, fast, and effective tool to eliminate bulges in the concrete and smooth the subfloor. Moisture and vapor barrier. If the space where installation to take place is a basement, a room with a high underground water level, or if the concrete floor is not completely dry, a hydro insulation layer should be installed first, before the underlayment installation, in the form of a 6 mil polyethylene film. The strips of the plastic film should be laid out overlapping one another 6 to 8 inches, so there is no space between them. The ends on the perimeter of the room have to be raised about 4 to 6 inches onto the perimeter walls. The excess plastic film should be cut off only after the baseboards are installed. Conclusions. Wood underlayment is a natural material, and therefore it is imperative to prevent a constant contact with moisture. Deformation protection space. Although the underlayment boards are laid adjacent to one another, a deformative space of 1/8 to 1/4 inch should be left between the boards and the perimeter walls. This space is designed to protect the floors from changing size and shape, deforming, in the event that a room temperature and humidity will drastically change. This space can be observed by placing discarded pieces of underlayment along the perimeter walls of the room and then start laying out the boards. Conclusions. The finished floors and/or the underlayment can swell, change size, if there is a severe change in the room moisture and/or temperature. To prevent the underlayment from expanding and breaking through the floor seams due to the swelling of the floors, it is imperative to leave space between the underlayment boards and the perimeter walls. Defects and bulges in the subfloor. Please note how the wood underlayment performs as a leveling tool when the subfloor is defected with multiple bulges. In our demonstration, we are using 3 screws as bulges or defects in the subfloor. Our underlayment is thicker than the height of the bulges in the concrete. Due to the elasticity of the wood fiber underlayment, it covers the defects and absorbs them into itself. Thus, the upper surface for installation is completely smooth and straight. Due to this functionality of the wood fiber underlayment, the defects are eliminated and will not interfere with the installation of the finished floors. Conclusions. The ability of the underlayment to remain sturdy and retain its geometrical shape on its upper level, while at the same time being elastic enough on its bottom layer to absorb into itself and eliminate subfloor bulges without breakage, is a unique and very important quality of the underlayment. Cutting and handling the underlayment during installation. Please note how easily the underlayment boards can be cut. You can cut out any size or shape of the board using any sharp object available underhand. Any sharp household object. A construction knife, nails, screws, a ball pen, a pencil, a metal ruler, etc. If there is a need to install the underlayment around columns or overcome various pipes, communication wires, and vertical enclaves, you can simply, using any of the objects mentioned above, mark the cutting location and then simply bend and break off the unwanted pieces with your hands. The elasticity of the board will allow for a straight and smooth break along the cut. Conclusions. During installation, the underlayment can be cut using either a sharp construction knife, which will yield a precise cut, or any handy, somewhat sharp object readily available, which will result in a more dull and dusty cut that can be settled with pressing it down with any heavy object. The second option is faster and simpler. Seams between the underlayment boards. During installation, to avoid spaces between the boards, wood underlayment boards can be attached together at the seams by any available Scotch tape. This step is optional. Conclusion. If the main purpose of using the wood underlayment is for sound insulation, then it is imperative to avoid leaving of spaces between the boards. Therefore, it might be a good idea to use Scotch tape to attach the boards. In all other cases, the use of tape is only optional. Installation of the laminate finished floor. Installation of laminate flooring should start from the window and continue in a perpendicular fashion. It is very important to adhere fully to the finished floor manufacturer's installation instructions. To maximize your finished floor's material utilization, we suggest to use the excess pieces of the current row, if longer than 20 inches, as the starting pieces of the following row. Conclusion. As experienced as an installer can be, we always recommend to adhere to the flooring manufacturer's installation instructions. Installation of baseboards. Baseboards are usually easily installed. They will cover the space left between the boards and the wall perimeter for unforeseen expansion and will enhance the look of the room's interior. Baseboards can be attached to the wall perimeter base by either screwing them into the wall or by attaching them to pre-installed clips. If sound installation of the adjacent rooms is desired, then the baseboards cannot come in contact with the finished floors. This can be achieved by leaving a space of 1/8 of an inch between the baseboard and the finished floors. After installation is completed, this space should be filled with clear silicone. Conclusions. Leaving the space between the baseboard and the finished floors will drastically reduce transmission of acoustic noises from the floors onto the walls and therefore noticeably improves the sound insulation in the room. End of the installation process. We have finally made it to the end of the simple process of the floor installation. Your floor is finally done. We hope your new floors provide you with comfort and you will enjoy them for many years to come. Conclusion. Thank you for your interest and for choosing wood fiber underlayment as your preferred product.